So in question 4 of the final exam review, we're looking at a two-dimensional projectile motion problem. The context is a golfer strikes a golf ball with an initial speed of 30 meters per second in a direction 40 degrees above the horizontal. It's known that the ball travels a horizontal distance of 68.9 meters. Determine the vertical position of the golf ball, final vertical position of the golf ball, assume that it's hit from yi equals 0. So we're trying to look for here is the final position of the ball. So I want to think about what equations of motion tell me about the final position of the golf ball. So we're looking for the final y position. So we could look at the equation that yf equals yi plus viy delta t minus 1/2 g delta t squared. Or we have a second equation that states that vf y squared equals viy squared minus 2g delta y, and the delta y would essentially be yf minus yi. So we can look at both equations and think about what I'm trying to solve. This is the variable I want to solve for. And what other quantities do I know? So if I take the first equation, I know what the initial, so we know what the initial position is, that's 0, so we know that for both. I can solve for viy knowing that I have the initial speed and the launch angle, but I don't know the time of flight, so that's a difficult piece for the first equation. Second equation is, again, I could try to solve for yf. I have yi, I have g. I could solve for viy squared, but I don't know the final y velocity. So I don't know the velocity that it hit just before it hits the ground. So in both situations, we have an unknown. We have an equation two unknowns. So let's see if we can how we can tackle this problem. I'm going to start here, since both equations require viy. Let's start with that. So if we think of the initial y velocity, this is our initial y velocity of 30 meters per second. It's at an angle of 40 degrees from the horizontal. This is our x component, this is our y component, and it's at 40 degrees. So this okay. So our viy will be equal to our v sine of 40. So that will be our 30 meters per second. Just to separate those. 30 meters per second times the sine of 40 degrees. You work that out on your calculator. You should get 19.3. And just in case we need it later, I'll work out vix, which is just equal to v times the cosine of 40. And noting again that that velocity does not change over the time over the flight, because there's no x acceleration for projectile, assuming no air resistance. There's a cosine of 40. So the question should probably explicitly state to ignore air resistance. And this works out to be 23. Okay. So those are the components. So you have to ask yourself the question, can I figure out delta t, or can I figure out vfy? Now, if you figure out vfy, you're actually going to need the time in the air. I don't believe there's any other way to solve for vfy unless I know how long the ball's traveling in the air. So if I take if I find the time that the ball's in the air, well, I can just go to that first expression. I think that's the recommended solution for this problem. So if we consider that how do I find this delta t? Well, there's obviously the delta t in this equation, but this is not helpful because I don't know delta t and I don't know yf. Delta t also turns up in another equation for the horizontal velocity. So I know that Vx equals delta x over delta t. the same time, so delta t is equal to delta x over vx. And those quantities we do know. We are given the horizontal distance the ball travels. So I can write this as 68.9 meters over the initial x velocities, which is why I've done this work up here, 23 meters per second, and that gives us the time of exactly 3 seconds, or 3 seconds. So now we know the time in the air. So again, you could go further to find VFY, but there's no need. Now you have everything you can to solve for YF. So the final Y position will be that initial Y position, which is 0 meters, plus the initial Y velocity of 19.3 meters per second, times the 3 second time of flight, minus 1/2 g, 9.8 meters per second squared, times the 3 seconds all to be squared. And this should give you an answer that the final Y position is 13.8 meters. So this will give you maybe a quick sense of what. Maybe we're trying to draw a picture. And you have that the ball travels quite a ways horizontally, so about almost 70 meters, and then finishes almost about 40 meters in its Y. So in some sort of elevated green or something that's in part of the golf course. So maybe the flag stickers up here, and the ball sort of travel something like this possibly. And so finishing again 13.8 meters when it lands, and a distance of 68.9 meters horizontally. So that leaves us with choice B as the correct answer.